All right, this video is going to go over writing equations of polynomial functions just when you're given their graph. So basically a polynomial function looks something like this. You're generally going to have arrows that either go opposite directions or the same direction. You're going to have places on your x-intercepts where you either cut through, you bounce off, or you do like a little swirly concavity change is what they call it. You're also going to have to know what exponent to give each factor. So let me just give you a little bit of a background before we actually start. You're going to have to add up these exponents. By the way, if there's not an exponent there, it means 1. You're going to have to add up these exponents. So like this one would be 6. And determine if it's even or odd. This one being 6 would be even. And the reason that matters is because it's going to kind of help you check yourself. So like I can look at this over on the far right here. I can look at this graph and instantly know that it's a negative odd function. So like when I add up the exponents, it's going to have to be an odd number. And by negative odd, I'm referring to the a value. It would have to be a negative number. So that's just something to think about. Also, when you cut straight through at your x-intercept, it gets an exponent of 1. When you bounce off, like here, I bounce off, that gets an exponent of 2. And then when you swirl through, concavity change, that gets an exponent of 3. So just keep that in mind. Okay, let's just go ahead and look at some examples. It should make a little more sense. Here we go. I have to write the equation of this graph. I can look at it and see that there are 3 x-intercepts. Advanced mathematicians, you probably know how to write that as a factor, like x plus 3. But if you don't, basically you just take this x-intercept, which is -3, and you just set x equal to it, and then make this number go to 0. So like add 3. X plus 3 equals 0. So that would be my factor, x plus 3. That's how I'm getting that. All right, so I've got a factor at x plus 3. And I know that it cuts straight through. So that means it has an exponent of 1 there. There's also a factor here at 0. So that's like x plus 0 or x minus 0. You can just put x. And it's a factor of 1, or power of 1 because I cut straight through. And then here at 2, I cut straight through as well. So it's x minus 2 to the power of 1. So this is the majority of my equation. The only thing is, there's an a value right here that you have to solve for. So the way that you're going to solve for this is they're going to give you a coordinate. I didn't write it on here, but I should have. On this graph, they gave me a coordinate of 1, 4. They will have to give you a coordinate. If they do not give you a coordinate, they're going to have to give you a y-intercept. All right, so I've got this coordinate 1, 4. I'm just going to plug it in for my x's and my y's and solve. So here's what I mean. F of x is basically the same thing as saying y equals. Well, y we're going to say is 4. So go 4 equals. Now a is I don't know because that's what I'm solving for. Now my x values, I'm going to be plugging in 1 for all these x values. All these x values are going to be a 1. So it's going to look like this. 1 plus 3 is 4. 1. And then 1 minus 2 is -1. Multiply it out, you would get 4 equals. This turns into -4a. Then you can just divide. And you could get your a value equal to -1. Now that's not your answer. Your answer is the actual equation. f of x equals, now I know my a value is -1, factor x plus 3, factor x, and x minus 2. Done. And if you're sitting there wondering if this order matters, no, it does not matter. I could have put x first. I could have put x minus 2 first. Okay, let's look at another one. I feel like the more you do on these, the better you get at them. And once you really do a bunch of them, it'll really start to click, and you can like look at this like this right here, and you can know instantly that that's like x minus 1 squared. But let's go ahead and look at the second one here. This second one, the first thing I would do is I would go identify my factors. So here's 1 at -1. That means I write x plus 1. Here's 1 at 0. So that means I write x. Here is 1 that bounces at 1. That means it's going to be x minus 1 squared. This bounce causes a squared. The other ones just cut straight through, so their exponents are 1. But bounces cause a square. All right, now I'm basically done. I just have to go get my a value. They gave me a coordinate on this one at -1/2, -27/16. So remember, this is my x, this is my y, and you're just going to plug them in here. So y is -27/16 equals, I don't know my a value, that's what I'm searching for. -1/2 plus 1 is 1/2. -1/2 gets plugged in for x here. -1/2 minus 1 is -3/2. And then squared, it becomes 9/4. I know that one was kind of weird. Okay, multiply it out. So this part did not change. 1/2 times -1/2 is -1/4 times 9/4 makes -9/16. And then of course my a, which I don't know. You'll have to divide by -9/16, which if you know anything about reciprocals, I'm just going to multiply by the reciprocal of this, which is -16/9 on both sides. Because these things cancel, like the 9 on top cancels the 9 on bottom, the negatives cancel each other, and the 16s cancel each other, and it just leaves like the a equals. All right, now over here, the 16 on top and bottom would cancel, the negatives would cancel, and then 27 divided by 9 is just 3. So I just found my a value as +3. Now all I have to do to finish this is write my equation. And by the way, when I do these, at the very end, I'm just checking a couple things to see if it makes sense. I'm checking positive a value on an even exponential one. So like this exponent was 1, that's not a good one. This exponent was 1, this exponent was 1, and then the other one's 2. So when you add those up, that's an exponent of 4. So the degree 4, and it's a positive a value, means my arrows should both be going up. That's kind of what I'm running through my mind as I finish this problem. Just something to think about. Okay, this last one. This is a factor at -1, so that cuts straight through. So it's like x plus 1. This is a straight cut through at 3, so that's x minus 3. Then same thing at 4 here. So that's x minus 4. These are all cutting straight through, so all their exponents are 1. Now I just gotta go find this a value. In this particular problem, they gave me the y-intercept. You can't really do it with the y-intercept when it's at 0, 0. But if it's off 0, 0, like this one at 0, 3, that's the coordinate I'm going to use. I'm going to use 0, 3 as my xy coordinate when I plug this in. So it's going to look like this. 3 equals. I don't know a, that's what I'm looking for. All right, now I'm plugging in 0 for these x's. So 0 plus 1 is 1. 0 minus 3 is negative 3. 0 minus 4 is negative 4. Multiply this out, you'd get positive 12. Then you can just divide and reduce, and you would get a equals 1/4. So now you can write your equation. And be done. And again, as I finish these problems, I'm going back and I'm seeing my degree of 3 and a positive a value. So degree 3 means my arrows are going to go opposite directions. Positive a value means it starts low and ends high. So this one kind of checks out with my a value that I just solved for. So that's just a couple examples on what you need to be looking for when you try to write these polynomials from a graph. Hope this video helped.